Good day to everyone in Korea and online around the world. It's wonderful to be a part of this ISOFAR conference and of the IFOAM 50th anniversary celebration. I was in the founding of IFOAM in 1972 when we sent Pauline Raffaeli from South Africa to represent us. And it's been great to see IFOAM growing as it has grown. In the talk today, I'm going to be covering comparing organic and conventional agriculture, and then also talk a little bit about the work with the African Union, which has looked at how we can mainstream ecological organic agriculture in the whole of Africa. So please share the slides. We're hoping that the slide will be visible to everybody. The title I've given is African Leaders in the African Union Adopt Ecological Organic Farming. And we'll talk a little about the Ecological Organic Agriculture Initiative at the end of this talk, but we'll start off looking at the work that's happening in South Africa. Next slide. So when we look at how farming systems have changed over the last 50 years, can we have the next and the next? And we see that when we started with chemical monoculture, we developed integrated arable and integrated pest management, conservation, agriculture, biological farming. Organic farming had been going for 100 years already, and so had biodynamic agriculture. But then we saw permaculture and the French intensive method. So the population is far greater in terms of the diversity of systems than it used to be. Next slide. And as you can see on the right, the movement of conventional agriculture towards agroecology has been quite significant. But in a way, we in the organic sector have not met it really. And I believe that we need to pull down this wall between conservation, conventional agriculture and organic agriculture, and begin to look at biological and organic farming as a continuum rather than an end point. And I think we'll see much more pressure on conventional agriculture to become more biologically sensitive. Next slide. Now, if we look at the research over the last 50 years, the Swiss DOC trials showed that organics yield about 20% less than conventional systems, but with better quality and lower input costs. In Pennsylvania, the Rodale trials were farming systems comparisons, and they showed organics yielding better in dry years, which is similar to what we found, but similar yields in wet years. And in Denmark, the International Center for Research into Organic Farming Systems looked at consumer and farmer research and addressed many of the problems, and was able to grow this sector by more than 10 times by addressing the research needs. In more recent years, we've seen a shift towards organic food systems with the UK Professor Leifert, who's now in Australia. In France, Professor Denis Lairon's wonderful work on looking at the impacts of organic diets compared with conventional diets on health. And Professor Carola Strassner has been working on nutrition in Germany. In Africa, we have the AU assessment, which I'll discuss at the end of this presentation, the work of Fibble in Kenya, work of Egypt and Morocco and Tunisia in North Africa. And as you know, Tunisia will be hosting the Organic World Congress in 2024, and hopefully we'll see a lot of the research showcased there. We'll be presenting on some of our work that I'll discuss today, the Mandela trials, the Agroecology and Climate Change Project, and TAFS, the Transition to Agroecological Food Systems, research that is going on in several countries of Africa at the moment. And then the African Head of States, the initiative after their resolution in 2011 to support organic farming. Next slide. So we see SAOSO, the South African Organic Sector Organization, having grown and developed next as an organization, PGS South Africa, working with SAOSO at the grassroots training of pollinators and facilitators. And we have more and more been getting working groups constituted as SAOSO grows and becomes a proud part of IFOAM Organics and the IFOAM Southern African Network. Next slide. So how do we approach agricultural development with the food systems lens? We decided we need to be an organic sector organization. We work on lobbying, advocacy, and policy, organic food production. I'm the convener of the working group on lobbying, advocacy, and policy, production, quality, processing, marketing, and SA participatory guarantee systems, working closely together. And more recently, working more with education, research, postgrads, training of farmers and consumers. And we have to work out what a sustainable food system looks like. And initially, we're working with farmers markets, with PGS groups, with processors, retailers, and wholesalers, and now starting to interact with cafes, restaurants, and caterers. And it is very much from the celebrity chefs that we are getting driving the move towards organics. People who appreciate quality food are calling for use of organic ingredients and local food systems. Next slide. So the research trial for the long-term organic comparative farming systems research trials at the George campus of Nelson Mandela University can be seen in the bottom of this photograph of our campus. We're located in George, which is between Cape Town and Port Elizabeth on the south coast of Southern Africa. And you can see the little red rectangle there where the trial sites are located. Next slide. When we started off, we thought we better do a baseline survey, and we estimated there was some diversity initially in the what we thought would be a homogeneous trial site. But initially, we planted an indicator crop, caliente mustard, and you can see top left of these 6 pictures, when it germinated, looked very healthy. The second one still looking healthy, and then as it grew, we began to see yellowing of the leaves and nitrogen deficiency, and a few weeks later, purpling of the leaves showing lack of available phosphate. And you can see the 5th and 6th slide, the crop was really struggling with poor nutrient because the soils of the Southern Cape are acid, low phosphate soils, and this is what we expected. So we then gave all plots, including the control, a ton per hectare of dolomitic lime. We plowed that in for each of the first 3 years, and we initially gave the conventional a good dressing of 2-3-4 and a good top dressing, and the organic plots got 27 tons per hectare of compost as initial dressings. But thereafter, only the heavy feeder crops, only the cabbage crops in the organic got only 5 tons per hectare. So the actual nutrients applied once we'd done this in the first year, thereafter it was only every 3rd year and only 5 tons per hectare, which meant that the cabbage got a quarter of the NPK nutrients of what the conventional got. So quite a tough trial for organics, and as you'll see, we had fairly good results. Next slide. Initially, the soil, as you can see, the control original in brackets, there was 4 parts per million, 4 milligrams per kilogram available phosphate by Bray 2. And with the lime, that went up to 10, but conventional with the phosphate fertilizer went up to 31 after 2 years. And the organic only went to 13, just a little bit higher than the control, because the compost we used was made with low phosphate ingredients and didn't significantly add to the available phosphate. The pH has gone up slightly in the organic trial sites. The acid saturation has come down below 10% in organic, which is good. Exchangeable aluminium hasn't changed much. Organic carbon, as you can see, dropped dramatically from 4.4 when we plowed to below 3, and has grown a little bit in conventional and quite significantly in organic with the addition of compost. Soil K and cation exchange better in organics, partly due to the higher pH in the organic trials. Next slide. So we realized that we had to look at both how the biology was changing and how the soil chemistry was changing. And in the 3rd year, we needed to supplement with rock phosphate, which is what we did. But throughout on the left, you can see the data logger, which measured rainfall, and also the cables go down to measure the soil available water in the top 6 centimeters of the soil, just under the mulch layer. And in the right-hand slide, you can see mulch being applied, and in the foreground, slightly to the left, the little gray cylinder, which is attached to a capacitance probe, which goes down to 1.1 meters. So every 20 centimeters in the soil profile, every half hour, we measure soil temperature and soil moisture. And you can see in a line going off to the right, each plot with its capacitance meter. The results that we got showed us 3 important things. Firstly, the mulch was reducing evaporation significantly, as we know it does. Secondly, as well as the mulch, we were able to isolate that the increasing organic matter meant that the soil was holding the water better in the topsoil layers. And also we found that the soil was holding available nutrients better as well as the organic matter grew. Next slide. So the organics did close the yield gap. You can see the chemical mean, the average rainfall and the chemical mean went up from about 50 kilograms of cabbage per plot to about 70 kgs with the better rainfall, and then came down in the conventional with the poorer rainfall in the third year, whereas the organics was reasonable, but 20% lower the first year, and the gap widened. Although the yield increased to nearly 50 kgs, the gap was now 31% lower. And then we fixed the phosphate, the available phosphate, with addition of 900 kilograms per hectare of rock phosphate, and the organic mean out-yielded the chemical mean. And we would like to say that was the end of the story. We closed the yield gap, but then in the next year, my student used poor quality compost because she wanted to buy in compost because she knew our compost didn't have a lot of phosphate, and she chose to buy it in from a poor source, and unfortunately there was very little nitrogen and very little phosphate in that compost. Next slide shows the fourth year's yields. And as you can see, a reasonably good rainfall, well distributed. The conventional mean went up significantly to a very good yield, but the organic mean dropped because of the crop running out of nitrogen, essentially due to the poor compost. The analysis of the compost only came through after we'd applied it, and it nevertheless taught us some very good lessons. What is particularly interesting is if you look at the conventional monocrop versus conventional rotation, you can see that in the fourth year, the monocrop did well, conventional rotation did very much better. And this was the first year that was statistically significantly better with the conventional rotation. You look at the organic, the monocrop did terribly. Bear in mind, it had very poor quality compost, and it was been cabbage for 4 years. The organic rotation, however, the cabbage crop followed the cowpea crop, and because of the nitrogen from the cowpea crop, you can see that the average of the organic rotation was 76 kgs, more than the conventional monocrop, and not that much less than conventional rotational crops. So it just shows how the conventional rotation benefited conventional, but with organic, you need good quality compost, you need a good rotation, you also need to make sure there's available phosphate, and that we showed and quantified very well in this research. Next slide. So as we know, the global carbon cycle, which is illustrated here, shows how on the right-hand side, the carbon that industry and transport put into the atmosphere is 7.5 billion tons per hectare per year. And a lot of this falls out of the atmosphere into the sea, and much of that evaporates back into the atmosphere, but the sea is getting at least 3 billion tons more of carbon per year and is acidifying as a result of that. On the left-hand side, you see agriculture's contribution. The vegetation has 550 billion tons, about 4 times that much in the soil. But look at the inputs, 60 billion tons per year going into the soil, and 62 plus 0.5 billion tons going out of the soil. So every year we are losing 2.5 billion tons of carbon from the soil. About 2/3 of that is from the destruction of forests, and about 1/3 from poor plowing. As you saw in our data, as soon as you plow up grassland, you lose a lot of the carbon, and it takes good organic agriculture to build the carbon up again. There's no doubt that organic agriculture can help agriculture to become not part of the problem, but at the same time, we need the industries and in particular transport to put less production into the air. So both agriculture and industry have to work to reduce global warming if we want to survive on the planet. Next slide. So in 2007, we met in Nyeleni in Mali, and the African Food Sovereignty Association started, and the 6 pillars were defined as focusing on food for people, valuing food providers, localizing food systems, putting control locally, building knowledge and skills, and working with nature. And where these 6 pillars are being respected, we're finding tremendous development of food production at local levels. But we're trying to understand African food systems and lobbying to move towards African food sovereignty. And we'll show you in the last few slides a little bit about how we're doing this throughout Africa with the help of the African Union. Next slide. So the Agra MVP, Alliance for a Green Revolution in Agriculture, Millennium Villages project, spent a lot of money. And in the first 5 years, that was about $30 million nearly they spent. And they reached about 90,000 people at a cost per household of $120 per farm per year. The export program for organic products from Africa, shown in the green, you can see in the first pair, only $2 million of total investment, much less than the Agra program. And yet 2 million farmers were reached and 200,000 were certified organic in Uganda in that same 5-year period. And the cost per household per farm was $2 per household per farm. And as Gunnar Rundgren said, who with Bo van Elzaker did a lot of this research in Uganda, it cost the Swedish taxpayer through SIDA about 1 cup of coffee each. Dramatic, and we're not saying IPOPA got it all right and Agra got it all wrong. Agra has built initiatives and has done a lot of work on training and on capacitating farmers as business people. IPOPA has linked people to their resources and linked. What we need for Africa is a combination of both these approaches. Take the good parts of scaling up in Agra and take the grassroots and ecological parts of IPOPA and combine them into developing sustainable food systems for Africa. Next slide. So we would hope that with the developments in South Africa since our democratic elections in 1994, that we would see less hunger and greater food security, greater child health. And indeed, if you look at here at the statistics in this bar graph, you can see that after the child grants were introduced in 2002, where every mother has access to money if they are in a vulnerable family to buy food for the children, the number of people saying that they are hungry has decreased. It's almost halved from about 30% of people to about 15% of people saying they're hungry. So that's good news, but is it reflected in better health of children? And unfortunately, Professor Devereaux has found that it isn't. The next slide shows the actual stunting statistics. And you can see that the child stunting rates in South Africa have remained stubbornly high. And Professor Devereaux looked at this in great detail. A lot of the money is spent on empty calories because of the loss of an African understanding of food sovereignty. A lot of people will go and buy Kentucky Fried Chicken or McDonald's or crisps, and these foods tend to be high in fats, in saturated fats and in calories, and very low in nutrients. So if we want to nourish Africa, we have to look at how we change our food systems, and that starts with how we produce our food. Next slide. So the quality of food, this is a comparative trial from Europe about 10 years ago, where we find that the 3 tall bar diagrams show the antioxidants in food, organic versus comparable conventional farms, 60% higher antioxidants in the organic milk. And on the left, the polyunsaturated fatty acids and monounsaturated fatty acids, the good fats are higher in organic, and the saturated fatty acids, the bad fats, are lower in organic. And on the right, you can see that some of the vitamins are significantly higher in the organic systems than the conventional. So not all aspects of food quality are better with organic, but many of them are. And Professor Dennis Lyron has also shown that this translates into health benefits. The more organic food there is in a person's diet in France, the study shows the less there is obesity, the less there is diabetes, the less cancers they're experiencing. So we're beginning to find the evidence is there to back the fact healthier outcomes, and the less obesity, but the impact on global warming is significant. we'll just look at what we're doing with the African Union. And next slide. And the typology that we developed, my biological systems consulting and research company, we got a team together with French speakers, Portuguese speakers, specialists, and Central and Southern African specialists. And we defined in the end where there is an organic policy, there's a product standard, there's strong government support, there's a national organic agricultural movement, which is the farmers being well organized, and there's both an export and a domestic market. And initially, there were only two countries, Morocco and Tunisia. And as you know, Tunisia is going to be hosting the 2024 Organic World Congress. And we hope that there'll be quite a review of the research in Africa, as mentioned. And we hope that we'll see how much progress there has been made. But what was very interesting is that after this work was published in 2019, both Uganda and Madagascar came to us and they said, we now have policies, we now have government support, we now have well-organized farmers, we need to be promoted to the evidence, and promoted them to type 1, and we were delighted that they wanted to be promoted. And this has helped us develop a monitoring and evaluation system which transition towards climate resilient agriculture. The active organic agricultural countries, organic policies coming, promise of government support, 11 of those. Infant EOA countries with no organic policy, maybe a product standard, little government support, 12 of those, including us in South Africa and many other countries that should be doing better but are not getting much support from government. Only a little bit of export in the nascent EOA type 4 and 10 countries there, and then very little happening in the type 5 countries, as you can see. So this converts into a map of Africa, as you can see on the last slide, which we hope will get gradually greener. You can see Morocco and Tunisia, who've done a lot of work over the last 30 years, and now Uganda and Madagascar, which have joined as advanced EOA countries. And the light green, the countries which are pretty active, where government is beginning to support. You can see the cross-hatching diagonally on the left, 4 West African countries that are part of the Ecological Organic Agricultural Initiative. And on the right in East Africa, where you've got Ethiopia, Kenya, Uganda, Tanzania, and now recently Rwanda as well. So 5 East African and 4 West African countries are part of the EOA initiative. And we're setting up a Southern African EOA platform, and we'll be setting up Central African and North African platforms over the next little while. So I think we can conclude that Africa is moving, and that organics in Africa is beginning to become mainstream, and that there is some political backbone to really motivate to get organic agriculture going. And I think we can stop the slide sharing there. And the basic what we will see in 2024 is how a number of countries in Africa have really dramatically changed the way they are doing ecological organic agriculture, whether it be agroecology or certified or uncertified organic agriculture. And the grassroots movement is beginning to spread, with so many of the mothers saying, we want traditionally acceptable, properly, naturally grown foods for our children, which have not been over-processed. So I think we can, as the Organic Food Systems Program linked to ISOFAR and to IFOAM, I think we can be proud of the work, the research work that's been done. But I think we can look forward to a lot of progress in Africa over the next 10 years. And it's been a pleasure to share our work with you. And we hope that the rest of the conference will go really well. Good luck to everybody. Thank you very much.